Cool.
Hey there, everyone. Glad to be here. I'm Daniel Buchner. This is Kuhn. We're from Microsoft. We're going to talk a little bit about decentralized identity and what we're doing to build that on the foundation of Bitcoin. So it's going to help to understand the problem of decentralized identity before we kind of get into how Bitcoin relates to this. The first thing to understand is when people talk about identity, they often conflate identity data and identifiers. But these are two very different things. Some examples of identity data are the tweets you tweet, blog posts, photos, all this stuff makes up your identity. Whereas identifiers are pointers to reflections of your identity. Things like email addresses or app usernames, those are your identifiers. We're going to spend a little bit of time talking about identifiers and app data, but let's dig in. So, Eric, why don't you talk about the status quo of identity today?
Yeah. So, the foundation of identity is broken today. You don't own these identifiers, and because of that, your
Can't hear you. Pick it up.
Take it outside if you want to talk.
Pick it up.
Pick it up.
Just eat your mic.
All right. So, identity today is broken. You don't own your identifiers, and because of that, your identity can be literally Thanos snapped away. You need right here.
Yeah.
Better.
Yeah, there we go. There we go.
All right, I'm gonna hold it. All right, so today identity is broken. You literally don't own your identity and these identifiers, and because of that, your identity can be Thanos snapped away. You need to own your IDs. Because of that, you might lose access to your connections, and without your identifier, you can lose your content. So this isn't a theoretical problem. We see this evidence everywhere. In this example, our friend American Hodl can be literally turned off from Twitter. You use these ID brokers to sign in to accounts, and if you lose access to that account, you'll lose access to all the new apps and services you sign up with. In addition, you send back data to all those centralized identities when you sign in. So we have the technology now to make this right, and Daniel's going to talk about that.
Yeah, so how do we make this better, right? Instead of an identifier like an email address or an app username that is essentially leased to you by a company, we want to replace that with IDs you own, the same way you own your Bitcoin keys that prove your value. So what we're doing is working with W3C, which is the standards body that standardizes all web technologies for browsers use every day. And what they're creating is a standard called decentralized identifiers. An example over here on the left of an identifier. It doesn't look like an email. It's a string, and you prove you own it because it's attached to a series of public keys and routing endpoints that can point to your identity data. So here again is the distinction between your identifier, the strong cryptography that backs it, and where you might point to find data about that identifier. So what is the root problem of DIDs, and how do we actually have to implement this? What's the core technical problem? Well, PKI, public key infrastructure, is really a problem of time. And I would posit to you that what Satoshi did was essentially solve deterministic time. We understand a lineage of events now that we didn't before. We didn't have this before Bitcoin. And it's the same problem with PKI. In PKI, when I create an ID and it's in a certain state, for instance, I associated it with a phone I had at first. I may have one public key attached to it, but then I get a new phone. And over time, it's changing. And you can see this with the example here of Theseus, the Greek hero. He sets out on for sail on his adventures, and when he starts out, the ship is in a certain form. Over the course of his journey, every plank and nail is replaced. But who saw it happen? If you were standing on the dock when Theseus' ship left, you might see a new ship come back, and you wouldn't know it was still the ship of Theseus, even though every board had been replaced. That is the inherent problem of DID. We need a system of record that understands this sequence of change over time. And so what can provide this to us? Let's talk a little bit about DIDs on Bitcoin. So what is ION? ION is an open source, public, permissionless layer 2 network that runs atop Bitcoin to provide you the exact form of decentralization that you would need for your identity that you get with money. Unlike other DID protocols, and there are many that are adherent to that standard, we developed it in a way that doesn't rely on any trusted validators, centralized authorities. There are no additional consensus schemes with Bitcoin itself, and no special utility tokens are required. Not even Microsoft has the ability to censor these IDs. They are yours. So 10,000-foot view, what does it look like? What does this topology look like? Well, anyone in the world can run an ION node. They basically contain a couple things. They contain an IPFS node for circulating the backing PKI data, and a capability to write Bitcoin transactions. So it's a highly aggregated network model where you might create an ID on your phone, and you can either anchor it yourself, anyone can if you can write into Bitcoin, or to save money, you might send it to someone like Microsoft or something else. Now that doesn't mean we're the centralization point, because when you send the operation to us to anchor an ID or to update its PKI state, you're signing it prior to you leaving your device. So if you send it to someone, the worst they can do is drop it on the ground. They can't mutate it or change it because essentially the operation is signed and cryptographically secure. So what happens is, let's say node 1's anchoring essentially an IPFS hash into Bitcoin. All the other ION nodes in the world are looking specifically for transactions that are marked in this way. Once they find the CID from the IPFS network, they look for that data. They try and triangulate it. And they all process the same data in a deterministic way. So it's an eventually strongly consistent system. Actually, I want to go back 1 second. Why do we use Bitcoin? Why do we get this question all the time? Microsoft, you wouldn't think we'd do this. Well, we use Bitcoin because it is by far, without question, the most secure and immutable network in existence. There is absolutely no debate about this. And for those reasons and those reasons alone, we choose Bitcoin. So what does ION deliver? Eric, you want to talk about some of the features?
Yeah, so ION delivers massive scale. Daniel talked about the different operations you need to do in the ship example, and we can do up to 10,000 operations in a given Bitcoin transaction. So that gives us up to tens of billions of operations annually, which helps us scale. Even if Bitcoin becomes $100, $500 per transaction fee, it's still economical since we're batching transactions. It will only be a few cents per op for a given user.
Yeah, and one thing to illustrate about that is that different data matters more or less than others, right? So PKI is incredibly important data. The ability to have an ID that may back things that are really, really precious to you, is it worth 1 cent essentially every time you would go get a new phone to do an operation? We think the economics make sense for this. You already pay for SIM cards when you go get new phones, right? That's all baked into your contract costs, but I guarantee you it's over 1 penny. Decentralized. This is a truly decentralized system. It's so lightweight. The ethos of Bitcoin and being able to run your node is actually even more important in ION. You want to be able to run your node and resolve identifiers securely. So we made sure that we added no real encumbrance other than storage in addition to processing logic. It is not a bottleneck on CPU. It runs really well on a Raspberry Pi. We have people doing it today, and I encourage you to jump in and do that. So one really important thing to note is that ION as a network is an intrinsic utility consumer. The core intrinsic utility, Peter Schiff talks about this a lot, Bitcoin does have an intrinsic utility. The fact that it can sequence events in time in a deterministic record, that is what it was. Money is a layer that we infer on top of that, right? So we're actually using the more raw aspect of Bitcoin in that sense. And we're not price sensitive. We don't really care if Bitcoin's price is $20,000 or $50,000. It continues producing blocks every 10 minutes, just like we need. So talking about a couple use cases here, Eric will kick us off with verifiable credentials and what we're doing with DIDs.
Yeah, sure. So the first use case that we're working at Microsoft is for verifiable credentials. So you use credentials every day. You had a pass to get into this conference. That's a credential. You might have an employee ID, a driver's license. Any of those things are credentials, and we're working with enterprises around the world to deliver credentials that issuers can give to a user in a verifiable way. So in this example, we're using that foundational element, that DID, and the issuer will sign this data object called a verifiable credential and include the user's DID as the subject. This is where it's owned and controlled by the user. Then the user stores this verifiable credential on their wallet. We've built a VC and DID wallet into Microsoft Authenticator. You might use that for 2FA codes. And then the user is able to sign another message, we call it a verifiable presentation, to prove that they are the owner of this credential. And the verifier in this case, Fabricam, who wants to know if you're employed by Woodgrove, can actually validate the signature of the presentation, so did they own the credential, And they can also validate the signature of the issuer. Is this Woodgrove's DID? So we're able to deliver a decentralized identity system for credentials that soon enterprises across the world will be using for their existing credentials today. And now Daniel's going to talk about the next use case, which is really exciting.
Absolutely. So one important point with the credential thing that I do want to make is that it's far more private in the sense that when you disclose claims through common protocols today like OpenID Connect, it's usually going through a centralized party. And so they're kind of aware of what you're doing on the internet. Now with verifiable credentials, it's directly between you, the subject who has issued a credential, and whoever is verifying. There is no middleman that you have to call home to. So that's one really huge benefit for privacy.
And additionally, the verifiable credential isn't stored on any blockchain. It's stored in the user's wallet, and that's the only place it is.
Yeah, and we'll touch on that a little bit here. Well, where is that actual identity data stored? Jack talks about Blue Sky and all these use cases that actually require data from you. This is the next component that we're adding. We landed Ion, what are we doing next? We're working on a standard for personal data storage, decentralized personal data storage servers, not a blockchain or anything like that, but essentially when I talked about that Ion document that's paired to your ID that contains keys and routing endpoints, you would route to your decentralized storage. That's where all of your data and app data is going to live, like your tweets and other things. So in this example, if Bob is able to exchange DIDs with Alice, he can inherently look her ID up, follow the endpoint to her data store, and start sending her encrypted messages and other things. So let's take a look at some use cases that are made possible through this. One, Signal, Telegram. We use these things. They're great, but gosh, wouldn't it be great if there was an international, universal, encrypted standard for transmission of messages that is baked into every browser and every application you use. You don't pick a protocol or app, they all use the same substrate. That's what we're trying to do with DIDs. Thinking about provenance and trust. You want to talk a little bit about this one, Eric?
Yeah, so this one kind of builds on the verifiable credentials use case, where if you're presenting your student ID for, let's say, Contosa University, how do you know that they are a real university? There's other proofs that the university would have, like are they accredited, or do they have insurance, or other identity data. So we built the ability in the Microsoft Authenticator app to go kind of query these things. The first use case is with a linked domain. So if a DID is requesting information from you, you can find out, did they connect that DID to their domain? And then we build on it with the hubs to say, are there other credentials that the user should know about to identify who you're about to share information with?
Great, and then one use case to illustrate something you probably all dealt with as you came here to this conference is what an Identity Hub data store does is sort of reimagine the world of apps around the user themselves. So you're essentially shifting the data from a centralized app server all over the place, strewn about, to the user. So imagine, if you had like Travelocity and Hertz and all of these car companies, if they're pushing this data to your data store in a semantic way that all of them can gain permissioned access from you to see, you can have a cohesive view of all of these things, and the data stays with you, secure and encrypted, and they're providing you the same utility, but it doesn't have to be resting with centralized companies that are subject to honeypots and other sorts of breaches. So thank you so much for all your time here. We really encourage you to get involved with Ion. It's up now. It's live on Bitcoin mainnet. Microsoft runs nodes. So do several other major companies. Ton of developers trying to work in this space. We created easy libraries so that you can create DIDs, you can do signings, create VCs, and run a node. We have a bare metal install on a Docker, and you can just, if you have a Bitcoin node you're all running, RPC into that and set it in your config, and you're good to go. Cool. We have about a minute for questions. So.
Hi, so if my understanding is correct, you guys are hijacking Bitcoin's PKI system and attaching some data to it, right?
No, it's actually Bitcoin's PKI system couldn't scale if you needed to do identity for billions of people and things.
Why not? You can generate as many addresses as you'd like.
Well, you might need to roll those keys every once in a while, and the whole point is if I roll a key, who knows about it, right? If there is no lineage, if there's no history, you can have an attacker that gets an old key of yours and says, no, I'm him. Right? So that's the entire point of a time chain, is that you have the immutable record of what this current state of an ID should be. Now, if you're saying all you're ever going to do is use burner addresses, yeah, you can do that. But here's the thing. DIDs will have public DIDs, right? If we want to replace Twitter, if we want to not have people deleted from these accounts, what we're going to do is you probably want at least one public ID that like lives a long time, and you're going to say follow my did, get my tweets from my data store, right? So you're abstracting those middlemen away. Oh, I think we're off. Yeah, sorry.